Till now we have seen, while storing a database file on the physical storage, one factor to consider is how to allocate the physical blocks of the disk to the file, whether the blocks should be contiguous or non-contiguous. The next factor to decide is how to arrange the records of the file within each block, whether the records should be unspanned or shall we allow the records to span over multiple blocks. Then should also decide how to arrange the records within each file, whether the records should be ordered or sorted based on some attribute or should it be unordered. And while choosing a proper file organization method, always the target is to reduce the I/O cost by reducing the number of block accesses required. So, even after choosing a proper file organization way, we make use of some additional access structure such as indexing for the fast retrieval of the records. Next, let's see the classification of indexing. One way of classification is dense indexing and sparse indexing. What is dense indexing? If for every search key value we maintain an indexed record, then it is called dense indexing. Consider this example. We know that every index entry consists of two fields. One field is the index search key and the other field is the pointer to the record or to the block containing the record corresponding to this search key. Here, let this be the field or the attribute which is used as the index search key. We can see for every search key we are having a corresponding index entry. Such an indexing is called dense indexing. Now consider this example. Here, for the search key A, we are having a corresponding index entry. For B, we are having an indexed record. For C, we are having an indexed record. For D, for F, for H, and so on. So here also, for every search key, we are maintaining an index entry or indexed record. This is also an example for dense indexing. Now, what is sparse indexing? If index records are maintained only for a few of the file records, then it is called sparse indexing. That is, we do not keep index entries for every record of the database file. Consider this. Here, we maintain an index record for the first record of every block. So for every database file record, we are not having an entry in the index. Thus, this is an example for sparse indexing. And check this example we considered for dense indexing. Here also we can see for every record we are not having an entry in the index. Index is maintained only for some of the records of the data file. For search key A, the block pointer will point to the first entry corresponding to A, and for search key B, it will point to the first record corresponding to B, and for C, it will point to the first record corresponding to C, and so on. So index values are maintained only for some of the records of the database file. Hence, this one can be considered as an example for sparse indexing as well as dense indexing. Because for every search key value we are having an indexed record, but index entries are not maintained for all the records of the database file too. The other way of classification is single level indexing and multi-level indexing. In single level indexing, if we have a database file, we maintain an index for it. And if the index file itself is very large, then we can consider the index file as an ordered file and we can create an index for it. And we can have the indexes at any number of levels. Such an indexing is called multi-level indexing. And the single level indexes are of the following type: primary index, clustered index, and secondary index. In primary indexing and clustered indexing, the database file will be kept ordered or sorted on the physical storage based on some field or some attribute, and in primary index, that key or the field on which the file is ordered, which is called the ordering key. In primary index, that ordering key will be the primary key of the file. That is, the file will be ordered based on the primary key, and this primary key itself will act as the index search key in case of primary index. And in clustered index, the file will be ordered based on some non-key, and that non-key field will be acting as the index search key in clustered index. So here the file will be ordered based on the primary key, and hence every record will be having a unique value for that key, and that primary key is used as the index search key. And in clustered index, the file will be ordered based on some non-key. Hence, for different records can have the same value for that non-key, and that non-key field will be acting as the index search key. And what is secondary index? Secondary index is based on some non-ordering key. That is, some field or the attribute on which the file is not ordered. Such a field will be acting as the index search key in secondary index. Maybe sometimes this file may be ordered based on the primary key, and there may be already a primary index existing for it. Otherwise, the file will be ordered based on some non-key, and there may be some clustered index existing for that file. But we know that a single database file can be ordered on just one attribute or one field. For all the other fields will be acting as the non-ordering field. And if more queries are based on the non-ordering fields of the file, then for the fast retrieval of the record based on such queries, we can maintain a secondary index on that non-ordering fields.